Picture this. You're a user. You want to get some data out of a JSON file. You're already in the shell. How do you do it? What do you do? You want to get the text out of a tweet. I don't know why you want to do that. Twitter's terrible, but maybe you want to do this for some reason. Great. So you look, oh, how do you do this with shell tools? And the answer is don't do it. It's a bad idea. Only bad people would try to do this. And then, obligingly, it's the internet, a bad person says, you just use this grep command. So let's try it out. Let's see how this works. So you can't actually use this API on Twitter anymore. Let's do something with GitHub. Let's check out the file. Okay, it's some big JSON file. Cool. So what do they say we should do? We want to use a lazy star, so it's going to be a message for the field, and then a lazy star up until without a backslash first, a quote, and let's do a comma just to be safe, and let's do it on commits.json. Okay, great, we got it out. Okay, let's check one thing though. I just wanna so I put that in there, but we missed it, right? If there were a backslash that was the last character, it's not gonna work. It sucks. Okay, let's do it in Python. Love it. We'll use JSON. All the commits are. Let me see how this works. I think I remember. All right, this is a little more verbose. This is cool. We're programmers. It's not a big deal. Where's the message? Was it commit? Okay. So I guess we need to to find all the messages. I guess we have to walk the whole thing. Okay, that's not so bad. You write a little program, right? A little recursive program that just walks the structure of the thing. Okay, that's maybe more trouble than you meant to go to, but it works, right? Commits.json. Okay, good. And I caught the last one, right? You see the last one's there? Great. Python, what could be bad? Let's try. I have JQ installed. Let's Okay, cool. It took me about a minute with the man page to write that up. That's not bad. I mean, spending a minute with the man page, maybe not worth it. What I want to show you today is this tool I wrote called FFS for getting data like JSON or YAML or TOML, the semi-structured data, into your file system as a way to work with it. So I'm going to start out by just issuing an FFS command to mount it up. This gives me a directory commits. Let's look in it. Right, so this directory has the structure of the JSON rendered into the file system. So if I want to find everything that's a message, well, I can use the find tool in the commits directory. Find me everything named message. Great, there's all my messages. Okay, pretty cool, right? So now they're in commit order. And now let's print them out. Okay, that was pretty straightforward. That flowed right out of my fingertips. Let's get the SHA out. So for each one of these, sorted, the SHA, so that's within the directory above. So I'm going to cut out the first 7 characters of the name. I have to have 2 levels up. Okay, cool. We've got the SHA out. And then let's say, okay, here's the SHA. Okay, let's try it in JQ. So I had to look this one up, but it was on their webpage effectively how to do something a bit like this. So what it does is we sort of build an object for what we wanted out. So it looks something like this. And when we run that, we get sort of the right output. The last one, that's the sneaky row where it didn't fit correctly. Okay, it's in JSON, it makes sense, it's a JSON tool. Okay, one last version. What if we only want to see commits that mention the word test? To do that in the shell, well, I can just go back to my loop, and then I can just say something like find test in the commit message, or we're just going to skip that iteration of the loop. Right, so I just took my existing loop, tiny adaptation, now we just see the ones that mention tests. So if you know the shell, that's pretty tough to beat. I couldn't figure out how to do that in JQ. I tried for about 10 minutes and then I gave up. So to me, this is compelling. This is a nice way to work with the data. How does it really work? So I want to demo a little bit of how FFS works by creating a new file and working with it in a couple of more nuanced ways. Let's start the -- new flag. Says, hey, I'm going to create a new file, so just start with something empty. We'll call it prof.json. This will be some metadata about me. So if we look, it's just an empty directory tree. It's just prof. It's just right there. So let's get in there, and we'll put in some information. So Michael Greenberg to name. Pleased to meet you. We'll put in my login there. That sounds cool. Let's make some roles. So what are we going to do? Well, I'm an author. I'm an advisor. I'm a teacher. I'm a sinner. I'm a saint. You know, all the usual stuff. My office number is 447 Gateway South. It's 447 in the office number. And that's good for now. Let's just say we're done. So we'll unmount it. Let's see what's in that file. Great, so this is a JSON rendering of that directory tree. So it's got the login and my name, and the office, you'll notice, is getting rendered here as an actual number, as a JSON, as a JavaScript float. So that's pretty cool. It got auto-detected. Less cool, but maybe more reasonable, is that, all right, it saved these role names. Like I had to come up with names there for role 0, role 1, but they're just roles, right? It should really be a list, and there's no notion of a list directory in POSIX. We can fix it. So there's this notion of types that I store in extended attributes in FFS, and that's going to sort of say how to serialize things back. So let's edit it in place and we'll fix it. Let's see, so Exeter is the tool on macOS for working with these. Let's see what we've got in prof roles. So user.type is named. Okay, so we want to change that. So let's make it, user.type should be list. These are the two types of directories. Let's unmount and see how that changed. Okay, great. Now you can see that it's appropriately generated that list. Very nice. Oh, but you know what? We want a headshot. It's a cool picture. So we'll add it. Prof.json. Do it in place. Sounds good. Let's copy. I've got it right here on my desktop because I use this in a bunch of spots. We'll put it in here. We'll just call the field headshot. Let's see what happens here. So we'll just unmount it. If you open it up, you'll see, oh, wow, okay, headshot. And then that's a lot of base64 data. But if you look at the last little bit of it, you'll see that all the other data's in there, too. So that's sort of a broad overview of what FFS can do. We're sort of mapping to and from these file systems. I've shown JSON, but it also handles YAML and TOML. I've shown a little bit how some of the types get used, how it can handle binary data. The examples I showed early on, I think, are very motivating for why this is the right way to do it. I think tools like JQ are great, but are a lot to learn and pretty quickly run into some limits. And without JQ, you're kind of back in the morass of programming. So I'm excited by FFS as a way to let the shell work with modern data. And I look forward to talking with you about it at PLOS. Cheers.